Okay, let's work through an example of finding a composition of functions where we have a restricted domain set for both of those. So we're going to find f of g of x and g of f of x. We'll go through both with those restricted domains, find their new domains. So go ahead and pause the video for a second if you need to copy those down, and then go ahead and start when you're ready. Part A, let's find f of g of x first and its domain. Now, if you just look how this is written, f of g of x, when we're working with the composition, we always want to work from the inside out. So we're going to take that inner layer, g of x, and replace it with what g of x is equal to, which is just x plus 3. That is a substitution, not multiplication. And now, let's find f of x plus 3. So in this f equation up here, we are going to pick up x off our paper, drop x plus 3 in its place, keep everything else the same. The 2 is there, the minus 5 is there. You do need parentheses because we'll distribute that through. And then let's just simplify here. We've got 2x plus 6 minus 5, or 2x plus 1. So that's the just equation. Again, that phrase explicitly in terms of x, that's what f of g of x looks like. It's 2x plus 1. But we don't know what its domain looks like yet. And this is a totally separate process. Really, the work is unrelated to what we just did. We're going to just take into account the layers of that composition and their domains. So let's walk through that. Okay, so finding the domain, we're really going to break this down into 2 steps. Step 1 is, if you look at how f of g of x is written, g of x is inside of f. If you're going to plug that into f, it has to fit in its domain. So step 1 here, we are going to put g of x in f's domain. Here's what that looks like. Let's take g of x and squish it between f's domain, which was 1 to 8. And just to keep myself organized over here, I'm going to put a little note that that is f's domain that we are currently considering, so that I don't accidentally use it again later when I want to switch over. Okay, so let's substitute again. So g of x comes out. What could we put in its place? Well, g of x is equal to x plus 3. And the 1 and 8 stay there for now. But ultimately, we care about what is x allowed to equal. So we've got to get at x by itself in the middle there. We're going to subtract 3 from all parts of this inequality. That turns it into x between 2 and 5. Now that is not the final answer. Because at this point, we have only considered the outer layer, f's domain. But if you, again, look at f of g of x, the very first thing you really do if you were evaluating that composition is put x into g. So step 2 is to take this, not the final answer inequality, and intersect it with g's domain. We have not considered g's domain yet. So I've got this -2 to 5, that's sort of this temporary pause, this little step that we have found. And now g's domain was given to us as x between 2 and 7. And we want the intersection of the two. That is finding all of the points that those two inequalities share or have in common, or where they overlap. So if you want to make it a little visual problem, we could here. Let's go from, maybe I'll go -3 to 8. Just fill that out real quick. And I'm going to draw those on a number line. So -2 to 5, that falls here. Whoop, make that a little straighter. Falls right here. And 2 to 7, that falls here. The intersection is where those points overlap or which points they have in common. So I could make them overlap here, and you can do that on your own on a number line. Just put them on one single number line. It is these values right here, which looks like 2 to 5. That is the domain of f of g of x. We have considered both layers at this point and how that impacts our function. So final answer here, let's summarize. F of g of x is equal to 2x plus 1. We found that earlier for x between 2 and 5. Let me point out two common mistakes, two things that we're not going to do. We did not just take the intersection of these domains right away. That's not how we approach this, okay? Because what happens is when we put x into g, it changes the numbers around a little bit, so we have to consider that in this process. The other thing we did not do is use this 2x plus 1 in any of our work in finding f of g of x's domain. So it really is two separate problems. You have find the equation, put that off to the side. Find the domain, put that off to the side, then bring the two together. Nowhere in this work here did we actually write 2x plus 1 until we wrote that as a final answer. Okay, let's go through g of f of x, same equations. In fact, I'm just going to delete this. We'll go the other way now. Find its domain. We'll go through a little faster this time, just kind of working through the steps. So the equation itself, g of f of x, f comes out. F comes out. What goes in its place? Well, f is equal to 2x minus 5, so that goes here. And now instead of g of x, we want g of 2x minus 5. So that's going to go here. Instead of x plus 3, we want 2x minus 5 plus 3. We don't really need the parentheses here. I just like to show them for substitution, but that turns into 2x minus 2. And again, we'll just kind of put that off to the side. That's my equation for g of f of x. But now, what is its domain? Let's do that part. Step 1, f is inside of g, so we're going to put f of x in g's domain. That looks like this. Take f of x and squish it between g's domain, which was 2 to 7. And I'm keeping track here, so I remember what I did. That is g's domain that we're considering right now. Now, let's take f of x out, and let's replace it with 2x minus 5. And then get x all by itself in the middle there. We're going to add 5 to both sides. And then we're going to divide by 2. Can I remind you that dividing by 2 is nothing kind of special in terms of what you have to do with that inequality. If we were dividing by -2, we would flip those inequalities around so that they said greater than or equal to. But that's not really an issue here. Now, that is not the final answer. I'm going to label this not the final answer, because at this point we have not considered f's domain. And in this composition, that's the very first function that we work with. X has to fit inside of f as well. So now, step 2, let's intersect that not the final answer with f's domain. Okay, so that looks like, I'm just going to copy this down again. We've got x between 3.5 and 6, and then f's domain was given to us as x between 1 and 8. Now, maybe you can just look at that and say, oh, I know what the intersection is, because really what you're doing is picking the inner numbers, so kind of the bigger number over here and the smaller number over there. But if that is a little too hard for you to do to find where they overlap, let's just make a number line here. I'm going to go maybe 0 to 10. And I'm going to graph both of those. So 3.5 to 6, that's going to fall right here. I'll put them right on the number line this time. 3.5 to 6. 1 to 8. I'm going to make it squiggly so it kind of stands out from the other one. 1 to 8 is here. We want the points where they overlap, and actually this one is kind of unique from what we've seen before. It is just that 3.5 to 6. Now, if you're going, oh, wait a minute, that's the answer I got before, that doesn't always occur. Sometimes, most of the examples that we've seen, when you take the intersection, you really have to change that inequality around, but this one happened to be just that, not the final answer step. Okay, so final answer, let's put it all together. g of f of x is this equation, 2x minus 2, for x between 3.5 and 6. Okay, come see me if you have any more questions.